Kia ora Year 12. In this video, I'm going to go through the first 4 parabola graphs in Mr. Hurring's lovely red and blue graph worksheet. So here are the first 2 that I'm going to do, and here are the second 2 that I'm going to do. I'm also going to look at the features of the graph with a special focus on the domain and the range. Okay, so this is my first graph. I'm going to do the blue one first, and there are 2 ways that I can find the equation of the blue graph. So when we're working with quadratics, we can either think about what the roots of the quadratic are, if we can see those easily, or we can think about where the vertex of the quadratic is. So if the vertex is at A, B, and we can see that, then this is the form that I will usually use. If the x-intercepts are A and B, then this is the form that I'll usually use. And in both cases, this scale factor is telling me how squeezed in or stretched out my parabola is going to be. We find k by using a third point. Okay, so let's take a look first at the blue one, because the blue one, we can choose either of those methods to use. So for the blue function, the first way I'm going to do it is by using the intercepts, the x-intercepts. So we can see we've got a blobby point here, and we've got another one here. So the x-intercepts are at x equals -2 and x equals 4. So that means that I can write the blue equation like this. Y is equal to something times x plus 2 times x minus 4. Right, and it's like that because if I take my 4 and substitute it into my equation, it has to give me a y value of 0. So that's why the 4 here gives me a factor of x minus 4 down here. So the next thing I need to do is to use a point somewhere on that curve to figure out the scale factor. And in this case, the point that I'm going to use is a different one from what I used in class. I'm going to use the y-intercept. So we know that 0, -8 is on the curve. So I can substitute that in. And that gives me -8 is equal to k times 0 plus 2 times 0 minus 4. You can see from looking that I'm going to end up with a k of 1. I've got -8 is equal to k times 2 times -4. -8 is equal to -8k. So going all the way back to year 9 maths, we get -8 divided by -8 is equal to k. K is equal to 1. There's actually a faster way to see the scale factor on this one here, and it's if you remember the pattern we had from way back in level 1. Okay, so just take that off. Back in level 1, we learned that if we went out 1 here and up 1 here, then we can look at if we go out 2 here, we're going up 4 here, out 3 here, and we're going up 9 here. So we're getting this pattern of 1, 4, 9. So we're getting our basic squared numbers. That's another way to spot that I've got a k value of 1, right? It's the simplest version of a quadratic. So that equation was pretty easy to get, I think, using the x-intercepts. Let's look now at how we can get the same answer by using the vertex form. Well, using vertex form, the vertex is where? Well, the vertex is at 1, -9. So that means my equation is going to have this form: k times x minus 1 squared take away 9. Now, why does this work? Well, I can see that when x is equal to 1, I'm at the lowest point on this parabola. This number here is a square number, so it's always going to be 0 or positive. It will be at its lowest when it's equal to 0, and that happens when x is equal to 1. Okay, so that's why vertex form works. All we have to do now is to choose a point to figure out the value of k. And so again, I'm going to use the y-intercept because it's easy. It's 0, -8. I could use these points here, though. I could use the x-intercepts, or I could use any other blobby point like this one here. But 0, -8 is pretty easy. So we've got this: -8 is equal to k times 0 minus 1 squared, take away 9. So now we just apply BEDMAS and clean this up. We've got k times -1 squared, take away 9. -8 is equal to k minus 9. I add 9 to both sides and I get 1 is equal to k. So my equation is y equals x minus 1 squared, take away 9. Now a nice thing to do that I'm going to do now would be to expand each of these equations and show you, oh, here I didn't write my final equation. It's a really bad thing not to have done. Just make sure that you do give the final one with the scale factor. So I've got those two equations. I'm going to show you now that they come out to be exactly the same when we expand all the brackets. All right, so we've got k equals x plus 2 times x minus 4, which gives me x squared minus 2x minus 8. This one here, y equals x minus 1 squared. Whoops, take away 9. Let's just expand that quickly. That gives me x squared minus 2x plus 1 minus 9, which is x squared minus 2x minus 8. So that's the first one done, and that's already 6 minutes of video. The last thing I need to do, though, is to talk about the features. So in this one, in the blue equation, that graph is going on forever. Compare that to the red one where I've got these two end points on it, right? So that's telling me that the domain for the blue one will be that x is any real number. It's fine to write that out in English, right? X is any real number. And the range, which is the y values it can take on, will be y can be any number greater than or equal to -9. Okay, so with that parabola, we can never get down here. The lowest value is here at the vertex. What about other features? Well, we've also got the vertex, which is at 1, -9. We've got the x-intercepts. So basically the features of a graph at any interesting points, -2, 0, and 4, 0. And the last thing that we've got is we've got an axis of symmetry. So we could take that graph and we could shove that line down there, and that's my axis of symmetry. So it's got reflective symmetry. So the axis of symmetry is at x equals 1. So that's the first graph done. Luckily, I'm only doing 4 per video. Now, the next ones will be a little bit faster because we've now hopefully got the basic idea. Let's look at this red graph. It's much littler because the domain is limited. Okay, so I'm not going to do the features for each of these all over. I'm just going to do them for that first one, but I am going to do the domain and the range. So the domain here is x from here out to here. So x is between -1 and 5. And the range we're actually going to figure out when we've got the equation, because we can't see quite what the vertex is here. Right, so because we can't see what the vertex is, we're going to want to do this one using the intercept form. Right, and the intercepts are, so the x-intercepts are at 1, 0 and 3, 0. So the form of the equation will be y is equal to k times x minus 1, x minus 3. Let's use another point to figure out what that scale factor is. Well, I can see this end point here is the point 5, 4. And I think if you are watching this and you're in my class, I think I got that around the wrong way today in class. So just go check in your notes that I didn't screw it up completely. So we're going to substitute that point in, and that's going to give me the scale factor. But just from looking at the graph, you can see that it's more spread out than the blue one. So if it's more spread out, if this is my basic x squared, if instead my graph looks more like this, then this will be a fractional positive number for my scale factor. And that's what we're going to find in here. So substituting the 4 into the y, we get 4 is equal to k times 5 minus 1 here, 5 minus 3 here. 4 is equal to k times 4 times 2. 4 is equal to 8k. K is equal to 4 over 8, which is 1/2. So we're done. We've got y is equal to 1/2 times x minus 1, x minus 3. So that's my equation there. And that's got a domain of We've done the domain. Now what about the range? Well, to get the range, we can see that the lowest value is going to happen here. Right, so it's going to be, the vertex is going to be halfway between those two roots of 1 and 3. So I need to substitute 2, x is 2, into my equation. So just erasing that mess at the bottom of the screen, here's what we've got. When x equals 2, y is equal to a half times 2 minus 1 times 2 minus 3, which is a half, times 1 times -1, which gives us -1/2. And that looks about right. So my range in here is that y can be any value greater than -1/2. And the axis of symmetry here is where x equals 2. So there are some features of that graph. Okay, 2 to go. Let's start by looking at the red one. I'm doing that one first because it's up the right way. So what do we know? Well, we know that we're going to get a k that is greater than 0 for the red graph. We can also see that this is really nice because it's symmetric about the x-axis. So that means that my equation is pretty simple. It's going to be y is equal to kx squared, and it's shifted up 3 units. So it's going to be kx squared plus 3, right? So here's my vertex. It's at 3. Now, if you want to go really slowly with that, you could write it out like this. K, and then you've got x minus 0 squared plus 3. But we don't need to worry about that, right? It's basically my very beginner one that I saw first back in year 10 that's been shifted up. Now we need a point. So let's use this point here. I'm going to use 1, 5 to find my scale factor. So 5 is equal to k times 1 squared plus 3. 5 is equal to k plus 3. 2 is equal to k. That means that my equation for the red one is 2x squared plus 3. And as I said, I'm not going to do all the features, but for this red graph, we have the domain is going on forever, so x is all real numbers. For the blue one, I've just got a limited domain. But the blue one is kind of similar to the red one because it also is symmetric around the y-axis. It's shifted up 9, and it's going to have a negative scale factor. So we can start by writing it as just kx squared plus 9, but we know that we have to end up with a negative scale factor because it's up that way. Now we're going to use another point to figure out what k is. Let's use this one here. So the point we're going to use is 2, let's see, 1, 2, lots of mess on here now, 2, 5. Substituting that in gives me this. 5 is equal to k times 2 squared plus 9. -4 is equal to 4k. K is equal to -1. So my equation is y equals -x squared. Let's see, have I got that right? Y is equal to -x squared plus 9. Just notice that in this one here, there isn't an axis of symmetry because it doesn't reflect on itself. And that's because the domain is limited, right? So if you were to take your ruler and draw this down here, you can see that if you flop it over on itself, it won't match up, right? So all of this bit down here will end up here and it will be different. So just be careful with that. No axis of symmetry in there because the function doesn't reflect onto itself. Right, that's all for now. I can hear the puppy has woken up. I need to go and look after her, so I'll be back later on, maybe with some cubic videos.